Hello students, good morning. So in this video I'd like to show you how does the positive and negative number work in a computer. And for the simplicity we will take just a 4-bit machine example. So a 4-bit machine have a register with only 4 bits of capacity, right? That's right. So first we will go for all positive decimal examples. So if you have 4 bits, then who is your LSB? The bit 0 is your LSB. I'm using pencil for it, or maybe here. And who will be your MSB? For MSB, I will just use pencil because I'm gonna erase this. So MSB. All these 4 bits will contain the value of the number. For example, my first possible number is what? 0, 0, 0, 0. In decimal equivalent, that indicates 0. Then the next possible number is 0, 0, 0, 1. And you know the decimal is 1. 0, 0, 1, 0. What's the equivalent? Decimal equivalent? That is 2. 0, 0, 1, 1. And that is the decimal equivalent of 3. If you observe, all these 4 bit patterns have the bit 3 and bit 2 unchanged and bit 1 and bit 0 changed. I would like to segment them. Okay, and I would like to put also a segmentation here. Okay, let's move on. So what are the next binary pattern? 0, 1, 0, 0. Decimal equivalent 4. 0, 1, 0, 1. Decimal 5. 0, 1, 1, 0. Decimal is 6. 0, 1, 1, 1. Decimal is 7. Here also we have reached the all 4 combinations of the right 2 bits, and the left 2 bits have the fixed 0, 1 pattern here. Now we move on more. 1, 0, 0, 0. Because after 0, 1, 1, 1, that is the next value. Then 1, 0, 0, 1. Then 1, 0, 1, 0. And the next number is 1, 0, 1, 1. So you can also observe again in this latest 4 numbers which have the decimal equivalent of, if you observe, 1000 means 8, 1001 9, 1010 means 10, and 1011 11. Okay, then the last 4 patterns, because we have a 4-bit machine, and what are the number of total possible permutation? That is 2 to the power 4. Okay, so we go for the last 4 patterns. That is 1, 1, 0, 0, 1, 1, 0, 1, 1, 1, 1, 0, 1, 1, 1, 1. So we have got all the 16 possible combinations of the 4-bit machine. Okay, so and the last 4 numbers indicate 12, 13. If you can check, you can check. 1110 means 14 in decimal, 1111 means 15 in decimal. Got it? Okay, good. Now, very important, I like to put the segmentation lines, and especially I want to segment the block that is at the very middle of the number range, and I would like to segment, I like to highlight it. This is my mid line. So when I go for, no, I'd like to zoom out. Okay, so when I go for negative number zone, what option do I have? We have signed magnitude system. I'll not discuss that in this video. We can also use 1's complement, and that's not my discussion topic in this video. In this video, for signed numbers, I'll go for 2's complement. So 2's complement. So all the positive numbers will be in normal form and their sign bits should be 0, and the negative numbers should be having sign bit as 1. So what is our plan? We will use the bit 3, the leftmost bit, as the sign bit. So this is no more my MSB. This will be my sign bit. So I override it as S. Sorry. Sign bit and bit 2, this becomes my MSB. So for containing the value, I have 3 bits, bit 0, bit 1, bit 2. And for containing the signal of the sign, I have to use the 4th bit, bit 3. So as long as I am moving down from 0, 0, 0, 0 until 0, 1, 1, 1, these 8 combinations have sign bit 0, it means all these numbers have sign bit equals to 0, and these numbers are in positive zone. Okay, and the rest of the numbers from decimal equivalent, which was decimal equivalent 8 to 15, but they have the sign bit as 1, so they will be having sign bit as 1, and they are indicating negative numbers. How? So let's see. When a machine is handling both positive and negative numbers, and you have all this range, like from 0, 0, 0, 0 to 1, 1, 1, 1, so that's all you have. We have to utilize all these 16 possible slots for indicating both negative and positive values. For positive values, we have decided that first half, that is first 8 slots, that has 0 bit as the sign bit. So these are all same for sign decimal system. We use for 0, 0, 0, 0, sign decimal has the same value 0, 0, 0, 0, 1, it has 1, positive 2, positive 3, positive 4, positive 5, positive 6, 0, 1, 1, 0, 0, 1, 1, 1 as positive 7. So this is same as for unsigned and signed system. But if I have a machine that has to also have handle negative values, what to do? The next range of the numbers, we have to take it in 2's complement form. When the sign bit is 1, we have to consider, when the sign bit is 1, we have to consider that this is a negative number and this is in 2's complement form. If it is in 2's complement form, it means it is in 2's complement. Okay, so if it is in 2's complement form, for example, if my number is already minus x, to find out the value of x, I have to negate it again. It means I have to find 2's complement of a already 2's complemented number. And if I can find the negation of a negative number, I can find the positive number, the value, absolute value of that number. So we move on. So let's begin the journey of all sign bit 1 holding numbers. 1, 0, 0, 0. In natural number system or in unsigned machine, it will be indicating 8. But my machine has to have handle negative numbers, so it is sign complemented form. So you begin complementing it. 0, 0, 0. They don't change. So what is this 2's complement? Let's see. Let's write down the 2's complement of this number. First 0, 0, do not change, again another 0, do not change, and then we get the first 1. None of them change. 0, 0, 0, 1. That is its 2's complement. It means the absolute value is, the number is negative, that's the first decision, and its absolute value is 8. We repeat this process for another example, okay? Then we will understand more. For example, we have a 2's complemented number, 1001. And how do we handle it? This is a 2's complemented number. It is already negative x. I have to negate again. And what's the negative negative? I have to 2's complement on this. I have to do the 2's complement. I get first 1, I keep it unchanged. Then the next 0, 0, 1, they get changed. 1, 1, 0. And if I take this as a value, I'm sure this is a negative number for sure. But negative what? The 2's complemented part of this. So this is 111 is equal to 7. Okay? We go for the next number. (1010). If this is already a minus x, I have to negate it. So I have to get the negation in the bracket. Okay? So do 2's complement. প্রথম 0 এবং তার পরবর্তী যদি 0 থাকে এবং বা ফার্স্ট 1 পর্যন্ত I keep it unchanged, 0 and 1. এরপরে যা যা ভ্যালু আছে সবগুলোকে আমি 1's complement করব। মানে 0 থাকলে 1 করব, 1 থাকলে 0 করব, 0 কে 1, 1 থাকলে 0. This is my absolute value. This is my positive x. Okay, this is my x that I am looking for. Okay, so I know this is negative region, negative world. It sign is negative, but the value comes from the 2's complement of the 2's complemented number, and this is negative 6. If I move on like this, you will find that all these values have this zone: -5, -4, -3, -2, and -1. So what you get in a sign machine, your number zone goes from +1 to 0 to 7 and -1 to -8 in a 4-bit machine. Okay, and for another extra bit, the total range will go double. So thank you very much for watching this video.